Here's a little diagrammatic representation of a protein going through aldehyde fixation. Tell me what all these little bars are, all these little crosslinks. I want to know what they are.
You're talking about iron nanoparticles. Now we're talking things that are nanometer sized. In fact, some of these have measured out about 100 nanometers in size, these iron nanoparticles. And according to Schweitzer, they perform the fixation. They cross-link the proteins. Now, again, I mentioned that the molecules that we use in fixatives to fix these proteins are angstrom-sized. And the reason they are able to fix these proteins is because they can surround the entire protein because they're angstrom-sized, and they can fix the tissue by that cross-linking process. And so you're expecting a nanometer-sized, in fact 100 nanometer-sized iron particle to do the same fixation that an angstrom-sized molecule does. It's kind of like using a trash truck to staple your papers together. Okay, you're using a trash truck to staple and immobilize your papers that are fluttering around in the wind, and this trash truck is going to staple them together so that when you pick them up, they're held by a staple and they don't move around. They're cross-linked. Okay, and so nanometer size, 100 nanometer size iron particles don't do the trick. Now let me make another point about this supposedly fabulous system of iron preservation of tissues. If iron preserved the tissues for 70 million years with the kind of stunning preservation that I'm photographing from these dinosaur soft cells, if iron could perform that, then why isn't it in my protocol manual? Okay? I'm a member of the Microscopy Society of America, have been for many years. I'm on the board of directors for the Southern California Society for Microscopy. Nobody that comes to present at our meetings has ever talked about iron preservation of tissues. And so if it is, as you say, a fabulously efficient fixation protocol that can fix proteins and tissues for 70 million years, then they should be in our protocol manuals. In fact, I should be able to find it in the latest edition of Weider's Functional Histology, which is the textbook for studying histology and tissue relationships. And of course, this goes into great detail to talk about fixation. So why isn't iron preservation in this textbook? Why isn't it in any of the textbooks or protocol manuals that we use for microscopy? Number one. Number two, why aren't the cryopreservation companies using it? You could run down and find a patent attorney, my friend, my critic friend. Run and find a patent attorney and get yourself a patent pronto for iron preservation of tissues, because the cryopreservation banks would buy that from you and you'd be a multi-billionaire. Okay? So go get your patent if this is such a hot thing and it really works the way you say it does, because it doesn't. In fixation, it is the amine groups that are cross-linked in proteins. Now, that leaves the whole rest of the protein, the non-amine portion of the protein, available for degradation and decay. And so, once again, if iron preservation can preserve these structures, beautiful, fabulous structures, for 70 million years, you need to go out and get a patent and get yourself rich, buddy, because you got something that nobody else in the world has. And so we'll wait and see if you go do that. So folks, thank you for watching this. Pass it around to everybody on your contact list. Thank you for your support. Remember that we need your support. I'm up against million-dollar labs with million-dollar budgets, and I'm the only creationist lab in the world doing this work. So I would appreciate your support. Thank you very much.